Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Green Stormwater Solutions for Healthy Waterways. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Atlan Stormwater. Atlan Stormwater is Australia's leading stormwater specialist. Working with councils, engineers and contractors, they build risk-free, clean water solutions for the future. Their products and services cater to every project, and their experienced team provides advice and support in sales, delivery, installation and maintenance. Today, we will hear from our speaker, Sam Cold, followed by an audience Q&A. And I encourage you to send questions through via the YouTube chat box. I'd now like to introduce our speaker for today, Sam Cold. Sam's career includes more than 10 years finding solutions in the stormwater space and being involved with Stormwater Australia's state committees. Working for a high-performance stormwater product supplier has given Sam the opportunity to connect with people, ideas and innovation to help fellow industry partners meet their water quantity and quality objectives. Sam's passion for clean stormwater comes from spending days at the beach, growing up swimming, kayaking and fishing, and wanting to share this with his kids. Please welcome Sam Cold.
Thanks for the introduction. Today I will be unpacking some of the innovative concepts our clients are using to not only achieve and exceed their water quality objectives, but also to provide additional habitat for microorganisms and larger wildlife, while saving space in their drainage design and reducing the overall cost of ongoing maintenance. I'll also touch on SQIDEP and the process of testing our systems under an independent framework. The way we choose to design our stormwater systems is linked to the overall purpose and design of our developments. Where possible, we look to find ways to reduce and reuse resources, optimise space, and use existing design elements, such as open water bodies that are already being proposed, for additional benefits, such as water treatment. The whole-of-life costs and of the asset we propose and how they can be incorporated into a circular economy with manufacture that considers end-of-life, reuse and recycling, and provides us with tools that can aid tackling complex issues like climate change and biodiversity while meeting local objectives for our projects. As advancements in stormwater treatment develop, they offer opportunities to help us meet some of the ambitious goals in sustainability and environmental management. This is a brief introduction to the solutions I'll be going through today. The first is the floating treatment wetlands. This is a favourite of mine due to its flexibility and potential to deliver additional benefits, particularly related to habitat creation, back to the community and the environment. And the second is the Atlan basin modular bioretention system. These products use the principles for water treatment we observe in nature and refine through testing and research to deliver improved performance and functionality for our clients. At Atlan, we are proud to increase the joy in water experience for as many people as we can. We like to bring our knowledge and experience together with the project knowledge of the engineering team to find the best design to meet and exceed the expectations and objectives that we've been set for the project, always with an eye on where we can add more benefits for our clients and the community. When we look at designing anything in life, whether it's a car, a mousetrap, a road or a wetland, we start with what we know works well and look to find improvements where we can. For us, nature has provided us with a baseline that works well, Through understanding the underlying principles she uses, we look to enhance these to deliver the best performance possible, while incorporating design elements that make the system easier to work with and maintain. The treatment principles we are using are nothing new. Nature has been using floating islands to process and remove nutrients and other pollutants from water runoff for thousands of years, just as it has with natural wetlands. We looked at the principles that were providing this treatment and developed our modular design based on our observations. We developed a structure that was easy to use and gave us the opportunity to control the layout and placement, making it manageable in the urban space and allowing us to bring the treatment concepts we found in nature to our clients' projects. A critical element of the performance and function of each island is plant selection. This often starts with a proposal from our team, and then we work with other stakeholders and take their comments on board to select the appropriate species that will suit the site and provide the desired outcomes. Some of our industry partners like to include native flowering plants to attract butterflies, bees, and other insects. Others ask for unplanted zones that become nesting areas for water birds, or internal water zones that provide a protected water surface for aquatic species. The roots below the islands and the plant structure above creates a unique opportunity to create habitat above and below the island and treat the water to a high level at the same time. The root structure is also important to the overall pollutant removal capacity, creating an ideal structure for biofilm formation. Part of our investigation into how nature treats water was looking at constructed wetlands and understanding how they work and what pathways they were using to remove nutrients and other pollutants. Constructed wetlands use complex flow paths and deep and shallow water zones to increase sedimentation, promote plant growth, and provide a structure on the stems of the plants that are in the macrophyte zone for biofilm formation, allowing nitrifying organisms to grow and process nitrogen. Floating wetlands use the same main removal pathways as constructed wetlands, but each of them is increased. The root structure in the water column provides more sedimentation, and the sticky biofilm also captures particles from the passing water. When the biofilm collects enough particles, it will fall off the root structure and settle to the base of the pond. The placement of the islands on the floating surface of the water means the plants are in their optimal growing location, regardless of the water level in the basin, increasing plant growth and nutrient uptake. And finally, the roots growing into the water column provides a significantly increased surface area for biofilm growth, which increases habitat for nitrifying bacteria and other microorganisms that process nutrients. Floating wetlands are a flexible solution to improve the functionality of our waterways and lakes. On a new site, we simplify the basin design by giving the option for a water body to be uniform in depth. On existing water bodies, we identify the optimal locations and select the appropriate position for the islands that works with the natural contours and flows in the lake or pond. By adding islands and their root structure onto the water body, we add the complex flow paths and replicate the deep water, shallow water, and macrophyte zones in the islands and open water section of the water body. You have a massive design feature when working with open water bodies as part of your development, and if used effectively, there can be considerable benefit not only to your water quality, but increased habitat creation, and it can be an effective part of reducing the likelihood of algal blooms as well. The Sussex Inlet Golf Village is a development we have been involved with on the New South Wales south coast. It's a residential development that used floating wetlands as part of its stormwater treatment. Close to natural bushlands and designing around an existing golf course, the developer wanted to use the existing water bodies if possible to help meet their water quality objectives and protect the downstream inlet waterways. The project was delivered in stages as the development progressed. After the installation of 200 square metres of floating wetlands in stage 1, the green and gold bell frog, which is an endangered species, was identified on the islands, and funding was approved to increase the floating wetlands as part of the stage 2 works. Around 550 square metres were installed as part of the stage 2 project. The modular design makes the process of increasing the footprint of the islands simple if additional treatment is required. The inlets to the lakes were pre-treated using Atlan vortceptors to remove gross pollutants, coarse sediment, allowing these pollutants to be easily maintained from a single location and holding the captured pollutants underground away from UV light. Then each stage of the floating wetlands was sized to mitigate the impact of the development in that stage. We have had clients use our floating wetlands as nesting habitat away from terrestrial predators such as foxes, and fish habitats using the root structure. We know it forms a great substrate for biofilms, and frogs have been seen in various locations. More commonly, we size our floating wetlands for water quality purposes, and our clients tell us the stories of the swans and ducks always sitting or nesting on the islands, or the fish swimming between the roots that their kids noticed when they showed them what they were doing. We have found that using nature's principles in one area, such as water treatment, often flows on to natural benefits in other areas. These photos show where the magic happens. These are examples of root growth after 6 and 12 months. And as mentioned earlier, the root mass serves not only to increase water treatment, but also becomes the building blocks for an ecosystem that forms around the floating wetland islands. Our latest improvement to our floating wetland design have been to offer more options and flexibility to our clients by moving to a smaller modular system. This allows us to adjust our layout and gives us more confidence in the structural performance of the system. The new modules come with a flotation pod for buoyancy and a planting tray that allows us to adjust the recommended media to suit our plant selection if required. I had a client who wanted to use bulbs in their plant selection, and we decided that we would replace the standard media from 1 in every 10 trays to have more soil layer so that it would be more likely that the plant would work. As mentioned, our smaller modules allow our clients to adjust the design to include internal open water or give them the aesthetic they are after, whether this is a longer shape or an irregular shape to suit the contours of the bank on site. Using our triangular modules and patented locking pins allows the islands to move with the water. Each connection can move up to 10 degrees up and down, reducing the forces that wave motion places on any given point of the design. Even in large island installations, the ability for each module to move relative to the module next to it means we can scale up our installations with confidence in the structural performance. Our systems have been externally structurally tested to ensure our anchor points and internal island connections exceed requirements of site, taking into account wind drag and water flow drag, and directing our anchor point and tethering designs. While our basket design encourages maximum interaction with the root surface and passing water. At Atlan, we are committed to testing our products to the highest standards we can, and part of this is the independent testing we've done on our floating wetlands at multiple locations to understand what these systems are capable of. We have studied nutrient removal microorganism communities to try and better understand what is happening in the biofilm and plant selection. We are aware of other papers that have investigated heavy metals, PFAS, and methane reduction. This is a photo of our Bribie Island field test site, which monitored the removal of performance along the length of the system. We are also currently involved in habitat trials with Edith Cowan University and are always excited to see the range of areas that the wider industry is looking into with floating wetland research. We commissioned an independent literature review of the nutrient removal papers available to guide us in our design process and removal claims, and this gives us confidence in the claims we make in the water quality space. As mentioned above, biofilm is one of the main drivers for nutrient removal in the floating wetland systems. As you can see, biomedia pellets commonly used in aquaculture and aquariums look to increase the surface area for biofilm formation as well. Any object that sits in a natural water body is likely to develop biofilm, and surface area is key to increasing the potential associated treatment. Biofilm is an active living surface that provides an environment for a vast range of organisms, and some of these help to process the nutrients from water. When we use roots as a substrate for biofilm formation, we create a surface that is much larger than comparable solutions, with each fibrous hair within the root mass creating an additional surface area. We studied the biofilm and identified over 3,000 species of microorganism present within these layers. And this thriving tiny ecosystem includes nitrifying and denitrifying bacteria, as well as consumers that process nutrients from the water column. The roots provide a carbon source as well as oxygen at times that allow the biofilm to thrive, and the diversity of the microorganisms in the biofilm makes it resilient to change. If the conditions in a water body shift, the population concentrations will also shift, increasing the species that are suited to those conditions and giving better performance for the biofilm in the long term. As previously mentioned, the plant roots play a vital role in not only taking nutrients and other pollutants from the water into the plant structure, but they also provide the building blocks for a healthy community of microorganisms. And this becomes the base of the floating wetland food web. Each layer in the biofilm interacts with the layers around and provides the nutrients and prey for the next layer. Healthy biofilm growth allows for increased processing of nutrients through this mass transfer process. 1 square metre of floating wetland with a metre of water underneath has the potential to create around a hectare of available surface area for biofilm formation. Even an equivalent volume of blue-green algae doesn't have that as much available surface area, and this helps the floating wetlands to outcompete algae for the resources, particularly over time. The processes in the root structure can broadly be placed into 2 categories, aerobic and anaerobic, and it's likely that there will be a balance of each in different areas of most large floating island installations. While both process nutrients using different pathways, we often look to the application we are working with to decide how to manage the balance. In natural water bodies, we often prefer to aerate the water, increasing the bioavailable nutrients and using plant uptake and nitrification processes to remove the nutrients. This creates a healthier overall water body, which is what we're looking for in open lakes and ponds. While also effective at removing nutrients, anaerobic conditions are mainly used where nutrient levels are extreme, and alternating between phases can produce higher volumes of nutrient removal. This is often in the wastewater application, where additional performance is desired and other life in the water is not as precious. Part of the anaerobic strategy may be to cover the open water body between the islands and isolate the water from both air and light. Natural processes in the water will then use up any available oxygen, and the anaerobic processes will take over. The advantages are that light that is needed for algal growth is restricted, providing the floating wetlands with an additional competitive advantage to remove more nutrients. One question that we're often asked is about the buoyancy of our system. The modules have been designed to be able to be walked around on to complete maintenance tasks if required, with enough additional buoyancy to account for plant growth. Each modular tile has a 45 kilogram additional buoyancy, and when installed and connected with other modules, they support and stabilise the neighbouring modules. I have a short video done by our Queensland Operations Manager. This video highlights the buoyancy and movement of each module with the modules next to them, as well as plant establishment after 3 months and some other design options.
Hey guys, Brenton Turner here from Atlan Stormwater, the Queensland Maintenance Operations Manager. Just up here maintaining the floating wetlands up at Dalton Drive. Just check this out. Beautiful condition, growing really well, really happy with how they're growing. All the greenery here, some of the other side, just looks absolutely beautiful. I weigh about 100 kilos, just sitting right in the middle, nice and supportive. Up at top again, looking beautiful, immaculate.
Anchoring and tethering are designed to suit the location they are being installed to. We understand that every project is different, and we have experience from a range of projects that allow us to customise the anchoring and tethering for the site conditions. This is an example site of a complex anchoring and tethering design. Our client wanted a floating wetland that wrapped around an existing island. They wanted to establish a barrier and create additional habitat. With this proposal came some challenges around how to keep the islands in place while providing capacity to rise and fall as the lake filled. We used strategically placed plough anchors around the installation and crossed the anchor lines under the wetlands to improve the stability and angle working on each anchor. We then manufactured brackets to attach the modules at each bend in the design to achieve the shape required for the island. This is the installed floating wetland. As you can see, we've created a secure island design that, when established, will protect the island, increasing the aesthetic appeal and creating additional habitat. Our modules have undergone a range of structural testing to make sure that they can cope with all the forces they are likely to see on site. Our modular design allows us to provide solutions which reduce risks when maintaining floating wetlands, including walkway options and removable handrails. Establishment is the highest operational cost for biological assets. Melbourne Water mentions 5 times the ongoing annual cost to maintain wetlands for each of the first 2 years of a constructed wetland. Our standard proposal includes a 12 months maintenance as part of the cost of supply to ensure that establishment goes as smoothly as expected, and we have an experienced maintenance team that are happy to continue completing the works themselves or educating an on-site team to do maintenance. Creating the optimum growing conditions allows our islands to establish quickly without a requirement for monitoring and adjusting water levels for plant health. As mentioned earlier, floating wetlands also eliminate the risk of your plants being covered in construction load sediment, which gives you the flexibility to establish and start treating your water earlier in the project. The quick growth and establishment of the selected plants also reduces the rate of weed recruitment by outcompeting for resources and space. And the reduction in footprint of floating wetlands compared to conventional wetlands reduces the whole of life cost of the asset. We can accommodate bird netting or plant protectors if desired, and can discuss these options with you to meet your desired outcomes. We've been involved in a number of small community-based projects that have engaged with community organisations and land care groups or councils to not only supply the islands, but also help educate on water quality, habitat creation, and the importance of our actions as residents, such as cleaning up lawn clippings and putting them in the green bin rather than washing them down the drain. Our hope is connecting with individuals in the community and getting them involved in interesting local environmental initiatives might spark an interest in water quality and give them a passion for looking after their local creeks and lakes. Floating wetlands can be used in a wide variety of applications, from water quality and remediation projects to habitat creation and controlling the desired aesthetic outcomes of a water body. When used for treatment, we can offer a reduction in footprint required and reduce both the capital and operational costs of the asset. The beauty of working with floating wetlands is often seeing multiple benefits appear as the project establishes. The second solution I'll introduce today is another product that replicates and improves on the principles of nature. That is the Atlan basin. This product is often used by our industry partners to replace rain gardens and bioretention in their design, saving them space and allowing flexibility in the stormwater design. Again, nature has provided us with the principles of water treatment, and it's our opportunity to learn from this and create a system that works with and enhances these principles and offers additional benefits to our clients' stormwater designs. On this project, the designer we were working with wanted the option to reduce the footprint of treatment to work around surfaces on a very tight site, while also offering a whole of life cost saving by reducing the complicated processes involved with best practice bioretention maintenance and meeting the green infrastructure requirements. We offered an ongoing maintenance proposal which allowed the client to consider and compare their options, and they were satisfied that the Atlan basin not only met the local requirements for water quality and the aesthetic brief they were looking for, but removed the risk of surface standing water and simplified their maintenance and ongoing costs. When designing the Atlan basin, the whole of life was an important element to consider. We wanted to simplify cleaning and maintenance and increase the lifespan of the treatment media. We did this by directing the water to an inlet pit and pre-treating the stormwater prior to the higher value treatment areas of the unit. This inlet pit design means that we can have a single point for regular maintenance. We remove gross pollutants as well as reduce sediment concentrations through hydrodynamic settling and a sediment filter before the pre-treated water passes into the tertiary chamber. The water flows into a drainage cell void around the perimeter of our engineered filter media in the treatment chamber. Once the water fills this void, it flows through the media to a central pipe system. This horizontal flow reduces the risk of the media blocking at the surface and allows our project partners to design a treatment system that surfaces multiple low points in their surface design by having an inlet pipe from a neighbouring low point enter the side wall of the inlet pit. Activation of all sides of the Atlan basin is the key element to allowing more water through our system by increasing the effective footprint for water to flow in the design, and allows us to reduce the required footprint, saving our clients space on site while maintaining a larger surface area underground. The latest science, both internationally as well as coming out of Griffith University in Australia, regarding the release of microplastics, highlights UV exposure as a factor in increasing the release of microplastics from gross pollutants present in the environment or captured in sediment basins and bioretention systems. The Griffith study goes as far as highly recommending in their conclusion that pollutants be removed from stormwater and held underground away from UV. This pre-treatment has been seen by many as best practice to extend the lifespan of the high-value assets within a stormwater design, and now the research is adding weight to the idea that pre-treatment is really important to the overall performance of a treatment train. The Atlan basin includes this underground pre-treatment as part of the inlet pit, whereas conventional bioretention often uses a sediment basin or the media surface to stop gross pollutants, and this leaves captured pollutants open to attack from UV light. The Atlan basin was one of the first units Atlan got SQIDEP verified. This process independently verifies our independent testing and gives councils a resource they can use to assess and compare stormwater treatments. This is our certificate and site photos. The process provides recommendations around performance and how the system is to be modelled and used on site. This is our test site. As you can see, the basin tested was only a third the footprint of the rain garden that was originally used to treat the water at this location. We retrofitted our Atlan basin and were able to demonstrate that we could meet the required objectives and effectively treat the incoming stormwater. When working with our clients, we have the flexibility to use multiple units wide or long to maximise the performance from the site footprint available. This can either be using side-by-side units or within a large pit or structure on site. As mentioned, the Atlan basin is fully independently tested and verified and is provided to site and commissioned by the Atlan installation team, so you can have confidence in the performance and the benefits because we take ownership of the delivery of the project from early design through delivery, installation, and hopefully maintenance. The long-term performance of our systems is our reputation, and we work hard as a team to make sure the system performs as it's designed. And we provide critical pre-treatment and pollution holding underground as part of the design to prevent gross pollutants from moving through the drainage network and discharging to the environment, where they can break down under UV light. Atlan is committed to testing our systems to the highest standards, and in the water quality space, Stormwater Australia's SQIDEP guidelines provide a great comprehensive place to start. The SQIDEP protocol provides an opportunity to compare the effectiveness of different styles of stormwater treatment used to meet water quality objectives. It ensures the samples are collected independently, sent to a registered, certified lab, and analysed and reported by independent academics, using a set of requirements that give confidence in the repeatable and representative nature of the results. Stormwater Australia then sends the report to members of their panel of industry experts to review the independent report and compare it to the protocol requirements. Once the expert panel have released their findings, a report detailing these findings is published on the Stormwater Australia website, along with a certificate of compliance. These documents provide transparency in the process and further contribute to the confidence in the process. Field testing and body of evidence pathways require that you undergo at least 15 events in the field, and each of these events must be representative of typical urban parameters, such as pollutant concentration. It requires the sampling captures the rising and falling limbs of the hydrograph for most events, and that the unit has at least one event above 100% treatable flow rate and another above 75% of the treatable flow rate to make sure that the system is not undersized. Atlan believes SQIDEP is the best available protocol, and we are committed to continuing our best practice testing of all of our solutions. This slide shows the products we have certified so far, and it gives authorities an independent assessment of the testing that is comparable from device to device. Thank you for your time today. I hope that you've gained some knowledge regarding the innovative solutions we use when helping to design stormwater systems. Now I'll pass back to you.
Thank you, Sam, for a great presentation and very informative. As always, it's now your turn to get involved. Please ask our Sam questions via the chat box, and thank you to everyone who submitted questions whilst registering. We might start off with some of those, Sam, and we had a question that came in from Ellie, and Ellie is watching from Victoria, asking you, what is the one big thing councils can do to improve our waterways? Thank you, Ellie.
Yeah, thanks, Ellie. Probably the main thing councils need to consider when they are looking at designing things to protect waterways is making things that are easy to maintain. The thing that's going to let down the design most is a lack of maintenance, and we're designing assets that are here for the long term, that'll perform for 40, 50, 60 years, and we're putting in a lot of effort to make sure that we're meeting the water quality objectives. In the long term, this is only going to be effective if it's well maintained, and so we need to make sure that we are designing in a way that can be easily maintained. So from Atlan's point of view, when we design any product, we certainly take in whole of life cost and maintenance, making them as simple to maintain as possible.
Thank you for that, Sam. And moving on into New South Wales, we've had a question from Michael asking you, Sam, how are sediments and TSS cleaned from a wet basin? Thank you, Michael.
Yes, thank you, Mike. It probably goes back to the previous question a little bit. It depends on how the basin has been designed and how the council wants to maintain that particular asset. So there are a number of different methods to clean TSS from a wet basin. I probably am not there are probably maintenance personnel that have more knowledge on this. some of the main methods are dredging, getting an excavator and digging out the base, as well as, depending on the design of the basin, being able to empty the basin and get an excavator into the base. So each basin will be slightly different in the way they are maintained. They are the methods that I'm aware of.
Thank you for that. We have someone, Yanto, he's watching from overseas, Sam, asking you, what are the most advanced green stormwater management technologies currently available for improving urban waterway health? Thanks for that question.
Yeah, I mean, we've gone through a couple of those from our product range today. Look, any technology that looks at the principles of nature and how they can be improved, it probably fits into that category. So the floating wetlands and Atlan basin certainly give a lot more flexibility and potential to bring what nature does into the urban space.
Thank you for that. And we move now into Queensland, and we've had a question that's coming from Ayub, and Ayub is asking, it will be helpful for decision makers if you could provide us with your opinion about using green versus proprietary stormwater treatment devices in small scale developments. Sam, your view?
Yep. Look, it's just my opinion, and opinions can be dangerous. But I see proprietary products as having value in treating stormwater, as long as they have been well tested, and I think the SQIDEP protocol is really important there. So when you've got confidence around the testing and performance of a product, I think proprietary products can add a lot of value. Every project is different. There are going to be projects where green infrastructure works really well and proprietary infrastructure works really well. I think as professionals, engineers should be given the flexibility to choose the direction they go with their stormwater management. I also understand councils have a place that they're making sure that quality stormwater design is going into their area as well. So I think there is a lot of value in having the flexibility to move between green and proprietary infrastructure, as long as it's well tested.
Yeah. Thank you for that, Sam. And Phil is watching this afternoon from New South Wales. Good afternoon to you, Phil. Is asking a question, Sam. What percentage of the upstream catchment do you need for each of your solutions to meet water quality objectives? Thanks, Sam.
Hi, Phil. Thank you for your question. Typically, for a floating wetland project, we start around 0.8 to 0.9% of the upstream catchment, and we start our modelling from there, and then we will run a music model and assess what is needed from a water quality space, depending on what else is in the catchment and what other treatment might be happening around the catchment as well. The Atlan basin is slightly smaller than that, so yeah, we start our design from about 0.4 to 0.5% of that upstream catchment. So yeah, we are reducing from the traditional treatment methods.
Thank you for that. Ben is asking you a question, Sam, asking you, has the floating treatment wetlands been used on temporary water bodies, such as sediment basin, on site? Thanks, Sam, and thank you for that question, Ben.
Yeah, thank you, Ben. So the design of the floating treatment wetland is to be installed on a permanent water body. One of the main reasons for that is the biofilm growth in the root structure and the importance of that to the performance of the system. We have some. There are parameters around water body health, and we usually like to see, an established water body and a permanent water body under the floating wetland system.
Thank you for that. Sam, we've had a question come in from Lucas. Good afternoon to you, Lucas, asking you, how are the connected modules units anchored to retain them in place within a water body? Thanks, Sam.
Yeah, that's a really good question, Lucas. It's very site specific, and it depends on the ground conditions and the style of island that we use. We have a bank anchor called a platypus anchor, which drives into the ground and holds in the ground, which can be used when the islands are coming close to shore. We also have what's called a plough anchor, which we use on mid-water islands. I've also seen concrete blocks used, and we've done some pillar design systems as well, where we've created an anchor point as part of a structure on the bank that we anchor our islands to. So we consider all aspects of the site that we're dealing with, and we do a detailed design as we come to deliver the project with our clients.
Thank you. And we've covered quite a lot this afternoon, Sam, green stormwater solutions for healthy waterways. Could you just sort of take us through the key takeouts from your presentation for our audience this afternoon? Thank you.
Yeah, I mean, some of the key takeaways, I believe, is when we start with the principles nature uses and we develop and improve them from there, we create a lot more flexibility. And we also add additional benefits outside of the stormwater design and water quality space to the developments we're working on.
Thank you for that. We have a question that's come in from Kerry. Sam, asking you, have there been any studies to look at these green solutions in the removal of non-nutrient-based pollutants such as heavy metals and PFAS?
Yeah, so the CSIRO has commissioned a study, and I believe that study is still ongoing with University of South Australia and WA. And so that looked into a number of different plants that have the potential to remove PFAS from the water column. So they looked at Phragmites Phragmites australis, I think it was Carex oppressor as the two modeling juncus. But yeah, there are studies regarding PFAS removal for floating wetlands.
Thank you, Sam. A question come in. Is there a maximum depth of water that the floating wetland is effective for?
There's not a maximum depth that floating wetlands are effective for. It's around the interaction of water with the root structure. So when the systems get too deep, you'll get some bypass water underneath the floating wetlands. So there are floating wetland installations in the US that have 5, 6, 7 metres underneath. I know a couple that are being used for methane mitigation, by inoculating the roots with methanotropic bacteria that are on quite deep lakes over in the US. Typically, we would be designing a lake that was, 1.5 to 2 metres is your typical installation.
Thanks, Sam. Glenn has sent in a question. Good afternoon to you, Glenn, asking, how often does sediment removal have to be done, say for gum tree leaves washed in? Sam?
Sediment removal is very site-specific. It depends on the upstream catchment and the basin design. In applications that are going to have a high sediment load, you can increase the depth of that basin to space out your sediment maintenance. Some of the main wetland guidelines recommend between 5 to 10 years for sediment clean out of an adequately sized sediment basin.
Thank you. Thanks, Sam. Shazad has just sent through a question asking you, Sam, how effective are these floating wetlands in controlling algae bloom?
They are effective at removing nutrients from the water column over time, and that is the main mechanism that they control algal blooms. So it depends on the size of the lake and the nutrient distribution through the water body. If there's not good mixture through a water body, what we recommend is that circulation is included so that the nutrients move around and move through the floating wetlands to make them as effective as they possibly can be. We certainly have a number of applications where algae mitigation is one of the primary uses for our floating wetlands.
Thank you, Sam. And just for sort of getting ready to close, but what do you see? Obviously, it's an exciting area. We've got young engineers entering the field, etc. What do you think are the key trends that we're going to see in the next few years coming up in this space?
Yeah, I think it's always difficult to predict the future. But I think reducing CO2 or carbon emissions will be a big part of the future. And as I sort of alluded to earlier, there's some studies out of the US that are looking at methane mitigation from vegetation that has come off hard stands and been washed into some of their lakes. So methane is also a greenhouse gas, and actually it's more effective or a more efficient methane greenhouse gas than CO2. And they've actually found that there are significant volumes of methane coming off some of their water bodies, and so having the ability to mitigate that is something that they're looking at in the US. And so sustainability and that ability to reduce greenhouse gases will be something that I think will be key going forward. I think we're moving towards a sustainable framework, and those sorts of applications are really important.
Thank you. Thank you. That's really optimistic looking forward. It is all we have time for today. We have come to the end of this webinar. It's been really interesting and fascinating, and great to see how engineers can support our healthy waterways. So please join me once again in thanking Sam Cold for his time and input today. I'd also like to thank Engineers Australia's industry partner, Atlan Stormwater, for their ongoing support. As always, if you could take a couple of minutes completing a short feedback form, which is linked in the description box below, it helps us to improve and plan for future sessions. Thank you again for joining us, and I look forward to seeing you at our next Thought Leaders event. Thank you and good afternoon.